Hey, grade sevens, it's Friday. Yes, it's the weekend. So, welcome to WorksheetCloud, grade 7 natural sciences. If you have a question during this lesson, send an email with your question to grade7@worksheetcloud.com. So today's lesson is on convection, which is a carry on from the previous lesson on heat energy transfer. In our last lesson, we looked at conduction, and today we are looking at convection. So welcome, good morning. I am Mrs. Hall, and I look forward to teaching you this lesson today on this beautiful Friday morning. So the objectives of our lesson today is to explain how heat is transferred through a liquid and a gas, and to also explain how heat can be transferred in terms of convection currents. And yes, by looking at this picture, our starter task is what makes an air balloon rise? And you are going to explain your answer. So let's start first of all with the definition on convection. Convection is the transfer of heat by the movement of a fluid. Now, when we speak about a fluid, we're speaking about a liquid or a gas. And it is between areas of different temperature. So the warm air is less dense than cold air, and so convection currents can form in the presence of a temperature gradient. Okay, and there's just a little diagram of an example of a convection current, and you will completely understand it by the end of this lesson. So let's take a look at why a hot air balloon rises. Okay, and you will notice on the right-hand side, while I'm busy speaking, that explain that stuff will be moving between the different levels, 1, 2, and 3, explaining, but I'm also going to go through it with you over here on my slides. So, hot air is less dense than cool air, so the heated air causes the balloon to rise simply because it is lighter than an equal volume of cold air. Buoyancy is an upward force that the air exerts, and it helps hot air balloons and blimps stay in the air. So a hot air balloon uses a burner inside to heat up the air inside the balloon. Okay, so over here we should see this should start moving now. Explain that stuff. Yes, there we go. Okay, it's now on number 3. Let's wait for it to get to number 1. So the balloon cools. The weight is greater than the lift, so the balloon falls. Number 2, the balloon is hot. The lift equals weight, so the balloon rises, and then the balloon heats up, and the lift is greater, and so the balloon rises. Okay, just a little GIF. Explain that stuff, and you will understand as we progress, especially when I need to speak to you and explain to you about density. Now, density is a word that you've all been learning about since grade 4, but it's always good to go back and recap and consolidate what it means in this instance when we are dealing with convection currents. So, density is a word we use to describe how much space an object or a substance takes up. In other words, it's volume. Okay, so there you have the little scientist, and there's a pillow, and there's a brick. So it is its volume in relation to the amount of matter in that object or substance. Okay, its mass. Another way to put it is that density is the amount of mass per unit of volume. So if an object is heavy and compact, okay, like this brick over here, it's heavy and it's compact, it has a high density. If an object is light but takes up a lot of space, like this pillow, it has a low density. Okay, so you'll start to understand it as we continue. So here we have another example in a scientific diagram. This is more dense, okay? This is less dense. So some things float and some things sink. And it's all because of density. So the more mass, okay? And the less air an object has, the more dense it is over here. You can see it, okay? More density, it will sink. And then the opposite is the less mass, okay? And the more air an object has, the less dense it is, okay? And then it causes it to float. I hope that made sense to you. So convection takes place in liquids and gases. As I said earlier, it's fluids. Convection will not take place in solids because the particles in a solid are too close together and can only move a little bit. Remember, in conduction, it's through solids and the particles vibrate, whereas in fluids, liquids and gases, the particles are slightly further apart and are able to move more freely. So let's take a little simple exercise you can do at home. You can look at convection currents in gases. So you cut out the paper spiral, you all know how to do that, and tie it on a piece of thread. Hang it above a turned on light bulb. So wait for the light bulb to get a little bit hot, your little lamp, and watch and describe what happens. Okay? So the hot, less dense air will start rising. It catches the paper spiral and it starts to turn it around. Okay, so you'll actually see the movement of the air. So here we have our gas and our liquid, our fluids in convection. It is a type of thermal energy transfer which occurs in liquids and gases. And here you can see the particles are slightly further apart, more so in a gas than in a liquid. Right, convection is the flow of heat through a fluid from places of higher temperature to places of lower temperature by movement of the fluid itself. Liquid and gas particles are free to move. Okay. Particles with more kinetic energy move from hotter regions to cooler regions, taking their thermal energy with them. So here we have another example. The hot air or the liquid is less dense, okay, than cooler air or liquid, so it rises. Okay, let me just move me out the way here so you can see it all happening. There you go. Okay, and stop moving. There you go. Okay, so the cool air or the liquid is more dense, so it falls and it sinks. This fluid is less dense because heat causes liquids to expand, in other words, to increase in their volume. The opposite effect, though, is observed in colder regions. Okay, fluid is less dense because the particles move closer together or contract or decrease in volume. And now let's take a more in-depth look at how convection currents work. Okay, there you have the arrows, the movement upwards, and the cold, more dense moving downwards. The warm moving upwards, cold moving downwards. Right, so convection currents in the home. A heater works by heating up the gases in the air around it. The gas particles start to vibrate and start to move further apart, which makes them less dense. Okay, so here you have the heater. The hot air obviously rises, that is the warm air, okay, and the cooler air sinks. The less dense gas will now rise and the cooler gas will move in and take its place. Okay, so the hot air rises, the cool air sinks. Okay. Here's another convection current in the home, exactly the same. Here's our heat source. The warmth of the water rises, the cooler water sinks, and it forms a convection current. Okay, the warm molecules, the cool molecules, and our heat over here. That's our transfer there, obviously from the hot stove or plates. It works the same in our fridges. Okay, there you have your convection currents in a refrigerator. The cold air will sink and the hot air will rise. Exactly the same with how an air conditioner works. If you look over here, the cold air sinks and the warm air rises. And now does it make sense to you as to why air conditioners are always placed at the top of a ceiling, not at the bottom, at the top. Okay, so they go high up on the wall because the cold air sinks into the room to keep us cool. And as the hot air rises, as it reaches the top of the ceiling, it's once again cooled by the cool air that then sinks down. Okay, I hope this is making a lot more sense to you now. And that little light bulb is going off saying, eureka. Okay, so let's take a look at convection currents and weather. So convection currents produce sea breezes during the day. So over here, you've got your ocean and you've got your land. During the day, the land heats up much faster than the sea. So air above the land is heated, and you can see the arrows going up there, the warm arrows, the red arrows. It expands and that air rises up. The cold air above the sea then moves inland to take its place, thus creating a sea breeze. And that's how we get a sea breeze. The hot air from the land rises, the cool air from the sea comes in. Okay. At night, the sea temperature drops slowly, okay, as compared to the land, which cools rapidly. So the land cools much more rapidly at night. The sea is now warmer than the land. The warm air rises above the sea now, and the cool air above the land moves out to take its place. And that is how a land breeze is created. So let's take a look at this, just a little bit of a recap here to place the statements in order. So in convection, here I've given you 6 points and you are now going to place them in the correct order. Okay, so these are your options. The less dense fluid rises. When a substance is heated, it expands. The warm fluid is therefore less dense. When it reaches the top, it cools and contracts. The more dense fluid sinks. The cycle of rising and falling is the convection current. So think about the order there, and then I'll go through the answers with you. You're welcome to pause me so you can make sure that you get it right and check yourself once I've gone through the answers. Okay, so let's get all the answers up in front of us on the screen. And number 1, okay, when a substance is heated, it expands. Okay, so there you go. Number 1, when a substance is heated, it expands. Number 2, the warm fluid is therefore less dense. Okay. Number 3, the less dense fluid rises. Okay. Number 4, when it reaches the top, it cools and contracts. Number 5, the more dense fluid sinks. Number 6, the cycle of rising and falling is the convection current. Okay, I hope you got that all right. Okay, a little bit of revision here as well. How does heat flow through solids? It's all answered with a C. Think about it. Liquids and gases are poor what, but transfer heat by something else. We make use of these currents in kettles and something else, heaters, and when cooking. Okay, all the C words. Okay, so heat flows through solids by conduction. Liquids and gases are poor conductors, but transfer heat by convection. We make use of these convection currents in kettles, convection heaters, and when cooking. Okay, so now you have a clear understanding between the difference of conduction and convection. Okay, convection currents in everyday life. So volcanic convection currents are the reactions to the heat energy within the Earth's core, causing a repeated rise and fall of the Earth's properties. The constant heat causes the same cycle to happen over and over. So as convection currents push the liquid material in the volcano's tube towards the Earth's surface. And here you can see the convection currents happening. The heated material here expands and rises, and we have the warm currents coming upwards and the cooler currents moving downwards. Okay, let's take a closer look at this. Little bit of video for you to watch. Let me get started. Okay.
Take a deep breath. Get ready for one of the most hypnotic things you'll
sorry about that.
ever see in a science class. Have you heard that heat rises? Well, here you can see it's true for yourself. I've got some food coloring on the bottom of a plastic container, and there's a hot mug right underneath the red food coloring. As it's heated, the water rises. But I want you to look closely and notice something else. The blue on the sides is being drawn in. You can see it better when I speed it up. Here's the thing I want you to remember. When water moves from one place, it doesn't leave a void behind. Water from somewhere else has to move in to take its place. That's why you can see the blue food coloring coming in from the sides. You can see it better from above. Watch that blue food coloring get drawn in. Do you see it? The hot water reaches the top, and then it gets pushed toward the edges by more hot water rising from underneath it. As it goes out to the edges, it starts to get cool, and cool water sinks just as hot water rises. And if you watch really carefully, you can see it sink and get drawn back toward the middle. These are called convection currents, and you see them moving here in two big ovals. They're one of the major things that drive ocean currents, especially in the deep oceans. But it's not hot water rising that drives the ocean currents. It's really cold water sinking up near the poles. Here's a piece of ice that I froze with some blue food coloring in it, so you can see how cold water sinks. As water sinks at the North Pole, for example, water has to flow up from southern regions to take its place. And these currents travel around the globe, some of them taking 1,000 years to complete their course. Understanding convection currents will help you get a grip on weather systems and the movement of Earth's continents over the eons, and even the workings of a lava lamp. If you want to try this for yourself, click on this link for all the directions you'll need. Thanks for watching.
So, grade 7, something you can do at home. A lovely little experiment to show you how convection currents all work.
Take a deep
Right, one other little video for you. This is to help you understand how the tectonic plates move and how volcanoes erupt. So another little video for you to watch. I hope you enjoy.
It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in two directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart. And it's this that ultimately causes the continents to move. Where the plates collide, the rock on the seafloor containing carbon from the dead plankton is carried deep into the Earth. As it descends, this layer of rock is heated, So the rock melts, releasing carbon dioxide. And gas is returned back into the atmosphere during an eruption. The remarkable cycle is complete.
So, grade 7s, I hope you enjoyed that lesson on convection currents today, and I hope you look forward to my next lesson, which is another heat energy transfer lesson on radiation. Like I said when we started, it is the weekend, yay yay, Friday. Take a load off, relax, enjoy yourself this weekend, have fun, be kind to your family members, and I will see you again next week.